it's recording. All right, lovely. Okay, so let's start with this problem here. So it's 65 CL to ML. So what does this mean? This is centiliters, milliliters. So for that, and I suppose you two don't have a sheet, so let me grab you one. These are not comprehensive conversion sheets. What I mean by that is there's many other conversion factors you'll be able to find out there. I just picked the most common that you'll see in this class, okay? When you go to take the test, I recommend looking at your course content folder. There's a sheet that says chapters 1 through 9, and basically all the stuff you need for all 9 chapters. That will have a more comprehensive list. The one that I think you really should have out for the exam that's not in that comprehensive list is this one that's metric to metric conversion factors. This is almost a cheat sheet that takes every single one of the prefixes and says what the conversion factor would be for meters, grams, and liters. Okay, so this one's pretty helpful. Otherwise, you'd have to use, so at the bottom of this conversion factor page where you see metric to metric, you would have to come up with those conversion factors on your own using that bottom portion. Okay, and I basically just kind of did that for you in that wider sheet. So, all right. So looking at this, whenever you approach a conversion problem, the first thing you want to do is figure out what type. Okay, is it metric to metric? Is it English to metric? Is it a temperature conversion, which we'll look at today as well? So to figure that out, you look at the units themselves. So if they have a letter in common, in this case they do, L and L, it's going to be metric to metric. Okay, so centiliters, milliliters. And the reason this helps you to identify the type is because then you know where to look for the appropriate conversion factor. It's going to save you a little bit of time if you know what type. So for metric to metric, you want to use this big sheet that goes across. And notice it's got the prefixes down the side. Okay, so we're looking at centiliters, so we're looking in the centi row. And then we're also going to look in the milliliters, so the milli prefix row. Okay, we're going to go all the way to the end where the liter portion is, so that last column. So you can see when you're looking at this that we're going to need more than one conversion factor. How do I know that? Okay, well, let's start with the centiliters. So if I find the centiliter conversion factor on that metric to metric sheet, what is it? What's the conversion? So 1 centiliter is equal to 10 to the negative 2 liters. Correct? Okay. So this conversion factor that I first find with the centiliters in it, it doesn't go to milliliters, it goes to liters. Okay, so what I've done, if I use that, I'm going to go from centiliters to liters. But I want to be in milliliters, so I'm going to need another conversion factor here to go from liters to milliliters. Okay. So this first step, I can use this conversion factor. But I'm going to need a second one. So for the second one, let's look in the milli prefix range. So what does that one say? Negative 2 or negative 3? 3. So this conversion factor goes between liters and milliliters now. So that will get me from the liters that I'm at right now to the milliliters. Okay, so this is a 2-step conversion one. Right? So now that you have all the conversion factors you need, you can start what we call the railroad tracks. Little plus sign is how it starts. And what's going to go in this upper left-hand corner is always the number in the question, the original question. So what number are we putting there? 5 centiliters. Okay, keeping the units with it. And so I'm here, I'm going to use that first conversion factor I found to get to liters. So to take this conversion factor, we have to figure out what part, the centiliters or the liters, is going to go on top, and the other part will go on the bottom. Okay? Now we want to cancel out centiliters, so which part's going to go on the bottom? Centiliters. So to cancel out the units we don't want, You need them on opposite sides of this horizontal line. This is a division line, so they cancel. I'm going to put my 10 to the negative 2 portion on the top. So if I just did this calculation here, I would be at liters. But I want to keep going. That's where the second conversion factor comes into play. With this one, do we want the milliliters on top or bottom? Top. Why? I want to cancel out the liters, so we need milliliters on top so that liters can go on bottom. That way, liters are on opposite sides. Those will cancel. And now all the units we have left are milliliters, and that's exactly what we want. So calculate this out. Remember, multiply as you go across, and then divide by what's on the bottom. So I get 65 times 10 to the negative 2 times 1. On the bottom, I get 1 times 10 to the negative third. Get 650. And it depends on your calculator. It might put it in scientific notation.
So that's easier than trying to do what we did last time for the negative, since it was 2 of them doing it twice.
Yep. And we did that when it was like a cube or a squared or something. And I'll show you another one of those. Before I do that, I want to show you a shortcut for ones like this, if you ever want to use it. The reason I didn't show the shortcut first is because it only applies to a small range of the metric system. It doesn't go all the way. For instance, on your sheet, it says mega all the way down to nano. So I'm going to show you just from kilo to milli, there's a shortcut. So a lot of people love this shortcut, but you don't have to use it because this way works fine. So I'm going to do this again, same problem, but I'm going to show you the shortcut. Get the same answer. So with the metric system, and you might have heard of this before, it's a representation of the prefixes. Okay, so what this KHD space DCM, these letters represent the prefixes in the metric system. Okay, so this is kilo, hecto, deca, a blank space, and we have deci, centi, or centimeters, centiliters, etc., and then finally milli. Okay, so there's a lot of mnemonic devices to help remember this the shortcut way. So one you might have heard is King Henry died drinking chocolate milk. I think the one that I've used in PowerPoints is kiss her dummy, blank, don't chase me. There's tons of them out there. So whatever one sticks in your head. So the nice thing about this is with the metric system, we're really just moving the decimal is all we're doing. Okay. Notice the numbers stayed the same. We still had a 6 and a 5 in our answer. It's just the decimal was now in a new place. So we can use this to figure out how to convert this number by just moving the decimal. This will help us figure out what direction to move the decimal and how many times. Okay, so how does it work? Well, this empty space here, this blank, that's called your base. So that's where the letter in common is going to go. So in this case, we're talking about volume. So our base is an L for liters. Okay? If we were talking about mass, the base would be a G for grams. Time, it would be S for seconds. Can't think of anything else right now, but there's always a base in metric to metric. In this case, it's an L. So what I'm going to do is I'm just going to put an L here, okay, as a placeholder. So how do I use that as a shortcut? Well, I'm going from centiliters to milliliters. What that means is I'm starting at the C, centiliters, and I'm going to the M, milliliters, right? So how many times do I have to move the decimal to get it from the C to the M? Just once. What direction? The same direction I just moved it. So I'm going to move it once to the right. Okay? If I go over here, There's no decimal point, but we said if there's no decimal, we always start at the end of the number. I'm going to start at the end of the number, and I'm going to move it once to the right, just like I did on that scale. Bam, there's my new decimal point. What's going to go in that empty space? A 0. So now I have 650 milliliters, so it's the same answer. And this works anywhere in the range from kilo down to milli. So if you have micro or nano or mega, you can't use this. You're going to have to do it that conversion factor way, which is why we needed to learn that way. I like to show the hard stuff first and help people understand it, and then give them the shortcuts. Okay. Another one. Let's try one of those cubed ones that we did. You'll need to know how to do for lab. I know we did a squared one in class. Let's try a cubed one. All right. So for lab, one of them is very similar to one in lab. It's just the numbers are different. I think you have to take a centimeter cubed, and it's going to ask you to convert it to a liters. And this one usually throws people through a loop. But we need to remember centimeters cubed is actually a volume, so we can do this. In lab, I gave everyone a conversion factor where 1 centimeter cubed was equal to 1 milliliter. I said that would really help you solve for some of these. So we're going to use that to help us in this one. Okay, so this will be one of the conversion factors we'll use. All right, so before we start doing our railroad tracks, let's make sure we have all the conversion factors we need. Okay, and I just told you that 1 centimeter cubed is equal to 1 milliliters. Okay, so remember centimeter cubed is cc. So, and we'll see that when we do the dosage lab. They're the same thing. So this conversion factor here will get us from centimeters cubed, because I don't need to write 1, to milliliters. Okay, but the problem is asking us to get to liters. So we're still going to need a second conversion factor. Well, milliliters, liters. What do you notice about that? Is it English to metric or metric to metric? Metric to metric. It's got that L in common, right? So you can look in your metric to metric table, long guy here, to find the second conversion factor you need. So you're going to look in the milli prefix range and go all the way down to liters again. What is that one? Is it 10 to the negative third? Use these enough, you'll start memorizing. So, all right, so this is where we're going to use the second, this is where we use the first. And this one here will get us from milliliters to liters. Perfect. So, do this conversion. Now that we have all the conversion factors we need, let's start with what's given in the original problem, 4730. Okay, so that first conversion factor, it's just a 1-to-1, but it's going to help us get rid of the centimeters cubed. We're going to want to put the centimeter cubed version on the bottom and the milliliters on the top. We're not changing the number at all with this conversion factor because it's just 1-to-1, but we are changing the units. So that's the purpose of putting that there. The next conversion factor will change the magnitude of the answer, though. So for the second conversion factor, now that we're at milliliters, we can use this guy. We want milliliters on top or bottom? On the bottom, so it cancels, and to the negative third will be on the top. So we're done. Now we can solve. We have 4730 times 1 times 10 to the negative third. All of that is over 1. 10 to the negative third, that means this number will get smaller by 3. I'm trying to do it without my calculator. 4. Now's the question, do I keep this 0 or not? So I need to go to my original number and check my sig figs to see if that 0 stays. Looking at this number, how many sig figs does it have? 3? 1, 2, 3. So this 0 doesn't count. There's no decimal, so it doesn't count up here. So if it doesn't count up here, we do not want to add it at the end of this guy. Okay, so 4.37 or 73. Because looking at it, I inverted the numbers anyway. So 4.73. Don't forget your units. It's always important at the end. Meters. The answer for that one. Questions so far? Okay, so this has all kind of been a review. So we're going to try a different one that we haven't done one like it before. And this time we're going to be converting to different units. So that's what's going to make this one different. We're going to take 1.29 grams per liter. Grams per liter, and we're going to convert it to kilograms per. We're going to convert it to kilograms per milliliter. Okay, so the reason this one is different is because we have two different units. We have grams, which is a mass, and liters, which is a volume. And we're going to a different mass and a different volume. Okay, so I want to write this out a little different so you can see exactly what this means. This means I have 1.29 grams for every 1 liter. Just a 1 assumed in front of this L here. And what I'm going to try to do then is in this top part, I'm going to try to get to kilograms. And in the bottom part, I'm going to try to get to milliliters. Before I start my conversion factors setup, my railroad tracks, I'm going to find my actual conversion factors. Okay, so I don't want to do the railroad tracks, start the calculations until I have everything I need. So I'm just going to separate it and look for both separately. So the top one is grams to kilograms. It's metric to metric because it's got that G, the grams in common. So what would be a conversion factor for the mass one? Okay, so that will get us from kilograms to grams. We just need one conversion factor for this top part. How about for the bottom part? We're looking at liters to milliliters. So it should be 1 milliliter. Into the 6? Yeah. I think it might be.
Oh, no, that's
third, isn't it?
That's mega.
Okay, you did mega. Okay.
You
Thank
did
you for
mega.
doing that though, because yes, this is milli, not mega. So keep in mind when you're looking at your sheet, there are 2 M's present. So pay close attention. Make sure you're looking at the milli and not the mega. That was actually very helpful. So these are the 2 that'll get us there. Okay, so how are we going to do this? We're still going to do it the railroad track way. We're going to start with the plus sign. It's just this time, before we always had just one number in the upper left-hand corner. This time we're going to have this whole thing. What that means is I'm going to start with my 1.29 still, grams, but I also have something to go below it. We just haven't ever had anything to go below it before. I'm going to have the 1 liter portion below it. We're still approaching it the same way. We're going to set it up. We're going to put these conversion factors in, 2 steps, 2 conversion factors, set them so we're canceling out what we don't want, keeping what we do, and just go about our way. And the nice thing about these ones, you can start with either conversion factor. Doesn't matter. So for fun, let's start with the bottom one. Most people would start with the top one. If we wanted to start with this top one, okay, so it's the liters and milliliters, we're going to put it right here. And what we're trying to cancel out is the liters. So do we want the milliliter portion on top or on bottom? It's going to have to switch. We want liters on opposite sides of this horizontal line. So we'll have the milliliters on the top, or not on the top, on the bottom. Told you it was a bad day for me. So the 1 milliliter portion on the bottom. This is kind of the opposite that we usually see. But the important thing is that the liters are on opposite sides of the line. Otherwise, they won't cancel. So they're on opposite sides this way, they'll cancel. So now I have my milliliters in the denominator like I'm looking for once I'm done. That's all this is it's kilograms over milliliters. Now we have milliliters in the bottom, so we're good there. So we're going to use the top one now to figure out this gram situation. We want it in kilograms. Using that conversion factor. We're trying to get rid of grams, so where's the grams going to go? At the bottom in this case, on opposite sides. And then the 1 kg will go on the top. Now the only units I have left are kilograms and milliliters, and that's exactly what I want. Kilograms per milliliter. Per just means divided by. Let's write out what exactly we're calculating. 1.29 times 10 to the negative third times 1. I'm going to skip that part. 10 to the third. You're going to get frustrated at this answer. Same thing, right? Did everyone get 1.29 or did you get something crazy? Did you put this in parentheses? Try that and see if it changes it. So remember when we're doing exponent scientific notation, if the scientific notation portion is in the denominator, put it in parentheses in your calculator. Let me know if you get something different. Oh, you might be right, because I did that in my head. This is what I have students doing calculations for me for. That will be a negative. Yes, and you're right. Thank you for correcting me. Some people are nervous too, and you know what? Instructors are wrong all the time. Especially when we're up on the board.
So the E in the calculator, they just need times 10?
Yes, so what you'll see in your calculator is E negative 6. Is that what you saw?
Mm-hmm.
So this E represents the times 10 portion. Whatever comes after that E, that's the exponent that you're going to put. So we're going to go away from this type of conversion and look at temperature conversions next. All right. So still doing conversions, just a different type. With temperature conversions, you need equations. You're going to be using equations. So figure out you have 1.8 Celsius minus 3 Celsius plus 32 equals Fahrenheit. Fahrenheit minus 32 over 1.8 Celsius. And then we have Kelvin, we have Celsius plus 270. Okay, so in the PowerPoints, I talk about Fahrenheit, Celsius, Kelvin, and their scales. And then I give you the equations. So we're going to focus on the equations themselves and using them. So we have degrees Fahrenheit. And to figure that out, we're going to take whatever the degrees Celsius is, multiply by 1.8, and then add 32 to it. Figure out Celsius from Fahrenheit. So if they give you the Fahrenheit, we're going to take the Fahrenheit, subtract 32 from it, and then divide by 1.8. I'll show you how to use all these equations. The one I wanted to point out was the Kelvin. So Kelvin is the SI unit for temperature. So it's the one, the scientific one that we usually use. To figure out this one, you go from degrees Celsius and you add 273. In the PowerPoint, I think I had 273 plus 0.15. So either way is fine. But when you round, this part's not really going to matter anyway. So if you look at the equation sheet you're provided on Blackboard, I don't have the 0.15 on the equation sheet. So you don't need to use it. So sorry about that difference, but I just did want to point that out. So let's look at an example problem and apply. So I have these written out as word problems on the PowerPoint. But I'm going to write the shorthand version up here. So what I asked was, if your temperature, like you take your temperature, like you should be doing daily in the times of a pandemic, and it's 98.6 degrees Fahrenheit. That's good, right? But we're going to figure out what is that temperature in Celsius. We lived in a different country. If we took our temperature, it would come out in Celsius. That's what the thermometer would read. So let's do that conversion. So to do this conversion, you need to figure out, what do I have? What do I need to go to? And that will help you pick the appropriate equation. So when you're solving for Celsius, this is the question mark one, right? You want to pick the equation where Celsius is equal to. That way you don't have to rearrange the equation. You're just going to take the Fahrenheit amount and plug it straight in. Right? So let's look at this. We have degrees Celsius is equal to, and we have Fahrenheit minus 32 over 1.8. So we're going to simply take that Fahrenheit and just put it in where F is. These are kind of nice. All right, so the trick for these ones, do the subtraction first, or else put it in parentheses. Otherwise, order of operations is going to take 32 divided by 1.8 first, and then do the subtraction, and you'll get a different answer. What you should get, I believe, is 37. Okay. And how we're going to do sig figs on this, since we're doing subtraction and division, and we have numbers in here, we're just going to give the sig figs that the original number had, just like we did with conversion. Okay. So if we have 1, 2, 3 here, 0.0, exactly. Add 0.0. I'm going to erase this just because I'm going to need more room for the next one. So 1. The one we're doing next, we're going from Kelvin to Fahrenheit. This is the hardest type of temperature conversion you will see, just because it's 2 steps. Okay, so if you look at these equations, you can see that the only equation that has Kelvin in it has Celsius. So I can't go from Kelvin directly to Fahrenheit. I'm going to have to go to Celsius first, and then from Celsius I can go to Fahrenheit. Okay, so it's actually 2 steps. So I'm going to start at Kelvin, I'm going to go to Celsius, and then I'll get to Fahrenheit. So I'll be using 2 different equations. Okay, so the first equation I'm going to use from Kelvin to Celsius, well, it's going to have to be this guy, because that's the only one I have that has Kelvin in it. So let's write that equation down. Now notice this equation I'm going to have to rearrange on my own. So to do that, I'm just going to take what I have in Kelvin and plug it in where the K is. I have 127 equal to Celsius plus 273. So we're treating this Celsius, this C, as an X, just a regular old math problem. If you had X and you wanted to solve for X, how would you do it? Subtract 273 from both sides. Okay, so this will cancel out, because plus 273 and a minus 273 equals 0. And then to figure out the degrees Celsius, subtract those two, we're going to get a negative number because 273 is bigger than 127. $146. And we're still keeping with the 3 sig figs, so we're good there. Now we're at Celsius. We're in the middle here. But we're not done because we want to get to Fahrenheit. So if we want to get to Fahrenheit, What one are we gonna pick? Where Fahrenheit is equal to, or the one where Celsius is equal? First or second? First one's gonna be easier because we won't have to rearrange it. We can take this Celsius right here and just plug it in where the C is. Let's do that. Figure out the Fahrenheit, we're gonna take 1.8 and we're gonna plug in for this C that we have over there at negative 146. Don't forget the negative. I'm multiplying 1.8 times negative 146 and adding 32 to it. So you will get a negative number. Sticking with 3 sig figs. You get negative 230.8. So if we're sticking to 3 sig figs, 1, 2, 3. Look at the number next to it. Does that stay a 0 or go up to a 1? It goes to a 1. Negative 231. I can write degrees Fahrenheit, but that's kind of redundant. Either way. Questions so far? Want to try one more? All right. Do it one more. We'll start at Fahrenheit this time. This is going to be we're going to figure out everything on this one. So we'll do 134. So this is actually a record temperature in Death Valley, California. It actually got this hot. And we're going to figure out what that temperature is in Celsius, but also Kelvin. So we'll do both. So we can use as many equations as possible and get the practice. Which one do we have to figure out first, Celsius or Kelvin? We go from Fahrenheit to Kelvin directly? Celsius, correct. So what equation? 1, 2, or 3? First one? So if we put the first one here. We want to put this where the F is. If we use the first equation, we're going to have to rearrange it. So if you think that, write it out once you see that.
So it's the second one.
Then we'll use the second one, yeah. So this one is rearranged already for us. We'll just make our lives a little bit easier. Both would work. So where the F is, up top here, we're going to put in that 134. 134 minus 32. And then on the bottom, we're going to have that 1.8. What was this record temperature in degrees Celsius? 4 minus 32. Or 102 divided by 1. Honey, can you come to all my classes and do the calculation? Well, you're even correcting me when I'm wrong, so very helpful.
I got 56 points and a whole lot of.
Okay. So 6 repeating. Sticking with 3. Nope, 6 repeating. That'll be 6, 6, 6. I'll just write a few of them. So let's count out. 1, 2, 3. That stay a 6 or go up to a 7. Stay a 6 or go up to a 7. Do 7. So it's a 6 next to it. So 5 or higher, you want to round up. And we are at Celsius, right? Yeah. Okay. So that's the answer in Celsius. Let's look at Kelvin. So we only have one equation for Kelvin. And this time we don't have to rearrange it because it's Celsius plus 273 and we have the Celsius. We're going to take the 56.7 and just plug it in where this C is. So this is going to be a fun one to round. So we want 3 sig figs still, right? 1, 2, 3. Look at the number next to it. Is that going to stay a 9? No, it's going to go up. So if that goes up to a 9, that means it's really going to go up to a 10, right? So that'll be a 0. But then this is going to have to go from a 2 to a 3. So it's going to be 3, 3, 0. But if I leave it like that, it's only 2 sig figs. That 0 doesn't count because there's no decimal. So how do I make that 0 count? Add a decimal. That's why sometimes you see a number with zeros and there's a decimal after it, because sometimes it means it to keep with the right amount of sig figs. And I almost was wrong because I need to put my units. Kelvin. So 330 with the decimal to keep with 3 sig figs, Kelvin. Any questions? All the problems I had on temperature conversions. Those ones are usually not too bad. So I still have a few minutes left. Do you want me to start talking about density or just do another conversion problem? Your choice. All right. I'm going to choose density, but if you would like to change that, that's fine. Just because that's what I would start on Friday. I post a video for Friday. It's going to be on density, so you might as well see it firsthand right here. So density is another nice one, similar to temperature conversion, in the fact that it's just an equation that you'll plug the information into. So density is equal to mass over volume. Okay, now the mass is usually in grams, not always. It is always metric though. So sometimes you might see kilograms, sometimes you might see milligrams, but it's usually grams. Okay. The volume is usually milliliters or centimeters cubed. So remember that conversion factor that we found, they're actually equal to one another. These are interchangeable. So it doesn't matter if you see milliliters or centimeters cubed, it means the same thing. Okay. And once again, there's not always milliliters. Sometimes it can be liters. But this is the usual. So I'm going to start with that and then we'll add on to it once we try ones like this. Okay. So to solve for these equations, sometimes they're straightforward where you're solving for density. But sometimes you're going to have to rearrange and solve for mass and volume. What I'm going to start with is just a straightforward one where you don't have to rearrange it. Okay, so I'm going to write a type of problem, and these are word problems, so it's kind of important for these ones to see the wording so that you can pick out the information and figure out what's what. So an example would be if I asked you to calculate the density of a 5-gram solution that has a volume of so this will be the most straightforward one you'll see. It's asking you to calculate density, the D. Okay, what you need to do with the two numbers in here is figure out what's what. One's the mass, one's the volume. Okay, sometimes it specifically tells you with a volume of, giving you a clue. But for the 5-gram portion, it doesn't tell you that that's the mass. You need to use the units. That's why it's useful to know the units to figure that out, what goes where. Okay, so this will be helpful in later chapters. You don't have to do it here. I like to write the variables. So mass is the 5 grams, and then volume is the 7.3. This is your equation here, right? Mass over volume, M over V. So I'm just writing the variables by it. It's going to be good practice for you later on as these get a little more complicated. So here, we just plug these straight into the equation. We're going to put the mass on top, the 5 grams, divide it by the volume, 7.3. And the reason I'm putting my units by it is that's going to help me figure out what the units of my answer will be. Because it's not always grams and it's not always milliliters. In this case, it is. So what do we get when we divide that out? 0.6849315. Okay, thank you. I'll stop. So we're still doing sig figs. Okay. So when we do sig figs, you're looking at the numbers in the question. So we have 2 numbers that we're dividing. So since we're dividing, remember the division rules are, we look at sig figs as a whole. Addition and subtraction is decimal point only. But we're not doing addition and subtraction, so we're counting total sig figs. So how many total sig figs in the mass? 2. The 0 counts because of the decimal. Okay, so there's 2. How about volume? Also 2, there's no zeros. So you pick the smallest, but they're the same this time, so it's going to be 2 sig figs. So let me go over here. Where do I start counting? 6. So the 6 and the 8 will be my second. Look next to it. Does that stay in 8? Yes, it does. So we're going to get 0.68. And for the units, this is why I wrote the units in my calculation, because that is the units on density. It will be grams per milliliter. Right. So we'll end with one more slightly different. So we'll do another word problem up here. Okay. What volume will 10.2 grams of benzene occupy given a density of 0.879 grams per mil? Okay. So for this one, I wrote a triangle over here that we're going to use to help rearrange the equation. So you'll see why in a second. So I'm going to start by figuring out what I have here. Okay, so it's asking what volume will 10.2 grams. So what is 10.2 grams? Is that the density, the mass, or the volume? You already beat me to it. Mass, yes. So that's going to be my M. Okay. What about the other number, the 0.879 grams per mil? It's the density. So density always has 2 units to it, whether it be grams per mil or kilograms per liter. Okay, it's always going to have 2 units. That's going to be my density. And so what the question is asking for then, what volume? So volume is my question mark. That's what I don't know. Okay, well, our equation solves for density. So we'd have to rearrange that to get volume, right? So what's going to help you rearrange that is what we call a density triangle. So you take the equation and you just put it in here with the density first, the M, mass on the top, and then volume, so dmv. So this is much like the railroad tracks. The horizontal line is a division line. Any vertical lines are multiplication lines. So how do I use this to solve for volume? The trick is, whatever you're solving for, you just cover up with your hand. And then you apply the order of operations to the remaining variables. So if I'm solving for volume, I'm going to cover up the volume, and I'm going to take the mass, divide it by the density. So this equation is going to be rearranged to mass divided by density. So M over D. So this is what I'll use to solve. Put that over here. My mass is 10.2. My density is 0.879 grams per mil. And this is grams. And notice, see, I wrote the units here. Grams are on opposite sides of this horizontal line. That means the grams cancel out, and that's good because volume should be in just milliliters. All right, so what do we get when we divide that out? No, thank you. No. We're looking at sig figs now. 3, 0 counts because there's between two non-zero numbers. Then we also have 3 here. So we want 3. 1, 2, 3. 8, 6. So our units on volume, if you don't automatically know it's milliliters, you write the units when you do it, you'll see what are my units that are left, just the ml. And volume is measured in milliliters, so that makes sense. What you'll see on Friday is me working through more of these problems. Okay, this is the last topic of the chapter, other than the definitions that you'll see in the PowerPoints. Okay, so I will cover more of these in a Friday video. We don't have class on Monday, it is Labor Day. We don't have lab on Monday, it is Labor Day. So if you have Monday lab, make sure that you do the online version of the lab that we're starting that week. Okay, so Wednesday is the next time I will see everybody. That'll be more of a review day for your questions. The test is going to open up on Friday, and you'll have until Sunday, the 13th, to complete it. And I'll give you more information on the test on Wednesday. How many questions, time limits, all that. All right, awesome. So here we go. Stop recording.